On the table here, mint in box, and I'm going to open it in this video, is a hairdryer. That's a volumizer type hairdryer that promises 30% less frizz and helps reduce damage. I have removed the shipping stickers from it, so you can actually see. Very importantly, this corner here, it obviously, as a product, works for 4.5 out of 5 stars of rating. Don't know how many people, don't know who put that there, but they claim that this works. That is important because this does not work. This is a knockoff brand without any kind of identification on it. This is its nameplate. And yes, while it worked, it did output 1,000 watts. But what happened to it was, obviously, it stopped working. So, once you pull out the guts from the machine that's inside the handle, this is what you end up with. It needed a woodworking chisel to open the housing there and there to slide off the end cap. And then we have this mesh. And then we have a rotary switch that leads to a sliding switch, which is kind of connected to this printed circuit board, and something doesn't work. Either the switch or the printed circuit board or the motor maybe burnt out. Something doesn't work. Maybe it's thermal protection. There is a thermal protection that cuts off power, and it failed intermittently. So yes, when this overheats, the thermal protection should cut the circuit and open, which is fine, but it just permanently doesn't work. So I'm gonna take a look at both of these and see how much better the brand name is, or what makes the brand name actually work. So obviously chose the same color variation. All right, let's see what are the observable differences at the get-go here between the two of them. Okay, so this is the one that failed. It doesn't have a power cord anymore. So the end caps are a little different. The difference in the shape of the molding, I don't know if that makes any difference. Probably not. It seems to have the same amount of cutouts for air exchange. They look like they are the same width, and this is not a circle, but the same diameter and circumference for both of them, by and large. And there's nothing functioning in this end cap here. All the electrical parts are mounted here. And how this works is the fan spins, sucks in air here at the handle, and blows out the air here at this end. So there's no electrical parts or any kind of parts here. The nameplate on this one is looking like this. Let's see. Yeah, it's a proper nameplate with a proper manufacturer, and with a, I guess, traceable model number, etc. So that's how this looks like. It also has a rotary switch with off and then 1, 2, and 3 power settings. I think that's the same on this one. So off was here on it, and oops, let's count the clicks. 1, 2, 3, yeah. So that's the same. The cable the power cord. This one is tapering. It's getting narrower and narrower, so it stays supple, like so. That's important because this one here broke. This one is not tapering. It's hard. It's somewhat flexible. You get it. But the jacketing on this cord broke. Does not expose the wires themselves because the wires are inside those jacketed wires, so it doesn't expose broken copper wires. But so this is nicer and promises to be longer lasting than the 1 month that the other one did. Second very important difference is that this cord is able to pivot like this. Okay, so somehow in the housing here, however they worked on the electrical connection, this is freely pivoting indefinitely, whereas this one didn't. As a result, this broke here. So the 2 tabs here on this molding here hold the cable in a fixed place. The 2 tabs protrude through that hole and lock it in place here firmly, and this one does not rotate. So the ends of the machines here look alike, but huge difference is that this one is pivoting, so that will make the power supply last years or indefinitely longer than this ever did, because rigid things and fixed things break when they are subject to motion, as one would expect on a hairdryer. So they're trying to cut some corners and it doesn't work. Next thing I do, just taking the cable tie off, is weigh everything before I look at the internal components. And this one is 518 grams. Cord, housing, everything. And this one is 434 grams. That's a lot lighter. Now, to be fair, I just compared the length of the cord between the two, and because copper is heavy, so on this one the cord is about a foot shorter than this one. So some of the weight difference comes from the fact that the cord is about a foot, this is about a foot, about this much longer on the name brand machine, a foot longer. One more thing, this is a metal surface there that has retained heat in this portion of the machine here as the air is exiting through it. So this has a heat capacity to this metal, whereas this is all plastic. This is a molded plastic surface. Molded as in injection molded. It's just a cheaply mass-produced all plastic component. On the table here I have the components of the knockoff hairdryer, and what failed on it is the cord itself. Maybe it failed here, or maybe it failed somewhere in the line. I want to point out this is a non-polarized plug, and most North American plugs are polarized, the neutral side being wider like this. The manufacturer didn't want to bother with that, so that means it could be plugged in this way or this way into the outlet. That's fine, that looks like a convenience, but the fact that it's not conducting electricity, that's not a convenience. So how do I know this? I have here 2 probes hooked up to a voltmeter, and it's set to continuity testing. Yes, beep. Yes, continuity. No beep, no continuity. So on these 2 wires here, continue in the cord and come out here. One of them is connected to one prong, the other one is connected to the other prong. So very straightforward. If I touch one probe to one side here and the other probe, say to this side here, obviously I found the brown wire conducting electricity flawlessly. Let's check the blue wire. Yeah, nothing. No beep, no power, no nothing. So I have to undo the soldering here. Very, very straightforward. That little bit of soldering there and that little bit of soldering there. Get rid of this cord. I cut this one off of a fan. The fan was dead, but its cord is fine. And I can cut it and solder it in no time. Yeah, I don't want this to be part of the system, so choppy. And then we'll clean the ends of the wire, like so. And let's test it for continuity, shall we? Ultimately, what's wrong with this hairdryer is the business decision that killed it. The manufacturer decided to use a type of plastic that's quite rigid or stiff. It's not really bending and it's not tapered either, and to mount it rigidly into the housing of the hairdryer instead of pivot it around freely like most everybody else's do. Because, hey, let's just be cheap and simple. So Cheap and Simple made this into a pile of garbage, or at least a project. Congratulations. I'm done with soldering in the new cord. Switch it to position 1. Whoa, it's working. Position 2 would be there. It's working. And last position, full power. Yeah, it is making heat and it's fully functional. I guess I'm done fixing it. Just need to put it back together.